Hi all, good afternoon. In the last session, we have discussed the features of Java programming language. We have discussed several features of Java. Can anyone list out those features?
Security, portability.
Very good. Other than security and portability,
Robust, platform independent, architecture neutral,
mm, architecture neutral, then multi-threading,
multi distributed and dynamic.
distributed and dynamic. Above all, simplicity and very good. Simplicity and object oriented, fully object oriented. Now, in this session, we focus on the fundamentals in object-oriented programming, and then we will enter into the first simple Java program. You know, there are different problem-solving methodologies are there in solving a real-world problem. As we discussed earlier, modular programming is divided into a set of modules. Structured programming is divided into a set of structures that we can say functions or procedures, like procedural oriented programming, object oriented programming, in which the entire problem scenario is divided into a set of objects and classes. Hence, in object oriented programming, the main focus is given in terms of partitioning or modularizing the given problem scenario into data and functions. Partitioning or modularizing the program into a set of data and functions. This is the main target of object-oriented programming. For example, in a C++ class, right? If you want to write class student, how will you define the members of a class? We can use the sections, private, public, and protected. For example, in a private section, we can define the variables. This is the variable declaration. Then after that, in a public section, for example, we can declare the functions. Declare the functions, or even you can define the functions as automatic inline functions. Define the functions. Functions can be declared under defined inside or outside the class declaration. When you define the function outside the scope of the class declaration, you need to use the scope resolution operator, right? Return type, then class name, scope resolution operator, function name, parameter list, opening curly brace, definition of a function, then closing curly brace. That should be provided following the class declaration. Now, the concept of a program, right, or the real world problem scenario is partitioned into a set of data and functions. This is a data partitioning, and this is the functions partitioning, right? So set of variables and a set of functions that should be defined. So partitioning, in what way partitioning, right, will be done means based on the memory allocation. So as far as class functions are considered, only one time memory is allocated. Void in data, void process, void print results. Assuming that these are the functions, the memory is allocated for these functions only one time. But variables are concerned, right? The private variables or the public variables in general, right? The data members are concerned, memory is allocated, Memory is allocated whenever you are creating the objects. So if you create an object 1, say O1, memory is allocated for data. And when you create an object of O2, memory is allocated for its own data. And creating an object, nth object ON, memory is allocated for its own data. But functions are considered only one time memory is allocated. Functions memory, right? Only one time. Why means each object can have its own value. For example, student is a class. Assuming roll number is the data, that means assuming roll number is a variable, right? For example, s1 dot roll number is s1 dot roll number is 1. Assuming that s2 dot roll number is 2, and assuming s10 dot roll number is 10. Now S1, S2, etc. Sn are different objects. So each object can have its own value corresponding to the data number. So to store the value of S1 dot roll number, you need to have one memory location. To store a value of S2 dot roll number, you need to have another memory location. So each data occupies the corresponding memory location. That's what we can say. Memory is allocated for the data whenever the objects are created. So for functions are considered only one time the memory is allocated, because S1 can access the function in data, S2 dot can access the same function in data, S10 can also access the function in data. So for all these objects, only one time memory is allocated to have the storage of a function. This is the logic of a memory partition for object-oriented programming. Now let us have a quick recap on the fundamentals in object-oriented programming. Fundamentals in object-oriented programming. What is the first concept in object-oriented programming? Yeah,
Inheritance.
not inheritance. Basically, right, you can say
Abstraction.
not abstraction. Before that,
Classes and all.
yeah, please you can say
Encapsulation.
object or classes. Before that, class. Considering a class, right, you can say class is a user-defined type. Class is a user-defined type. User-defined types are said to be ADTs. What is ADT? Abstract data type. We can have our own class student, class, for example, reservation, a class cancellation. So classes are completely the user-defined types. Class is a concept of static concept. Again, considering the object, objects are user-defined entities. User-defined entities. Each object occupies part one. Each object occupies its own memory. This is important concept in object-oriented programming. S1, sample S1, memory is allocated for the object S1. Sample S2, memory is allocated for the object S2. Sample S10, memory is separately allocated for the object S10. Each object occupies its own memory. If you say the collection of objects, right? Collection of objects form a thing called class, where object is which concept? Dynamic concept. Class is a static concept. Why objects are said to be dynamically one means dynamically we can create the objects. At runtime, right, we can create the objects. But classes are defined, right, at the earlier time. So classes are said to be, right, a static concept. Class object, the third one, abstraction. Before going to see, right, what is encapsulation? Abstraction provides only the essential information without in-depth implementation. Hope you understand. It abstracts, right, what is actually needed, but you cannot know, right, how the implementation will be done. In even, right, in this example, right, if you say, right, class student, here, right, you can define some function, declare some functions, void, right, get input details, void compute, void, right, print details, something. So seeing that, right, this is overall abstraction, how student information is going to be processed. But you will not understand, right, how the functions are going to be implemented. Simply saying, you can see, right. So seeing this, right, what I can conclude, seeing this page, right, what I can conclude. Some of you are live. Understand? That is a what is the concept of abstraction? Can't you understand, right? Or the classification of abstraction. This is just a data abstraction. So seeing the names, right, what we can conclude means some of you are live. That's all. Overall idea is some of you are being live. That's all. But I cannot know, right, how you are listening, right, or what are you actually doing. That cannot be determined, right? So there are two kinds of abstraction. One is a data abstraction, and another one is a procedural abstraction. What is a data abstraction? Seeing the information, right? Say data, right? We can conclude that. For example, 10, 24, 35, 56, something. So seeing this, right, we can conclude that these are some integers. Suppose are positive integers. But we cannot say, right, for what purpose, right, the integers are returned, because these are data, right? So using the data, we can simply conclude some overall information. Likewise, right, if you write a function, for example, void sqr or sqar is square root, we are defining a function. For example, in the C style, just assume simply write have only the declaration function prototype. So void square root. So seeing this, what will you conclude or what will you infer? This is a function to be declared to find out the square root of the given integer. For example, if you pass one integer value into x, what can you conclude means this is a function. This function is going to find out the square root of the given integer by passing one integer value, and the return type is of a square, return type is of a void one, right? So this indicates that the function will not return any value to the calling place. Understand or not? Understand? Any queries in this? No responses from your side? Any doubt in this? Getting me or not? Please speak with me.
Yes, sir.
Okay. So using this function declaration, right, we can just conclude that a function square root is declared, right? The function takes one integer parameter to which the square root is going to be computed. That is the only inference we can have. But we cannot know, right, how to compute the value of the square root of the given integer. That is completely hidden, right? So that's what, right, the classes are said to be, right, abstract data types, and classes achieve a property called data hiding property. Data hiding, how the data is going to be implemented and how the data is going to be accessed, right? Simply outside functions, right? I cannot access the private data. Private data is the secured one. Private data cannot be accessed outside the scope of a class. That is said to be a data hiding concept. So two kinds of abstraction, data abstraction and the procedural abstraction, and another one is data hiding. Next one is encapsulation. Encapsulation just encapsulates both the data and the functions into a single one. Data and the functions are combined into a single class unit. The single class unit is said to be encapsulation, like a student class that encapsulates several data and functions. Then sixth one is inheritance. Inheritance is the process by which one class acquires the properties of another class. There are several kinds of inheritance: simple inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. That is a simple inheritance, only one base class and one derived class. Multiple inheritance can have several base classes. Multi-level inheritance can have the class hierarchy from one level to the next level, from A to B and then from B to C. Hierarchical, only one class can be hierarchically divided into same level derived classes. Hierarchical inheritance. Combinations of, right, multiple multi-level or hierarchical that results in a hybrid inheritance. In C++, we have seen that a base class derived class relationship. Where in Java, the base class is said to be a superclass and the derived class is said to be a subclass. Superclass subclass relationship. Java does not directly support the multiple inheritance, right? Instead, multiple inheritance can be achieved with the help of a interfaces concept. Another one is polymorphism. Polymorphism is an important object-oriented programming concept, right? Poly, right? More than one. So polymorphism is characterized by the phrase one interface, multiple methods. One interface, multiple methods. Can you give an example of polymorphism? What are the examples of polymorphism?
Overloading.
Function overloading, operator overloading.